This is quiz, oops, oh, I didn't change that. This is quiz 2 for pre-calculus. So the first question is considering the function f of x equals negative the square root of x plus 2 minus 3. The first question asks us, what is the domain of the function in interval notation? Okay, so the domain of the function is all of those x values that we can plug into our function without getting something that's undefined. Now the problems, the things that can make our function undefined, are when we either divide by 0 or take the square root of a negative number. Here we don't have any problems with division by 0, but obviously we could take the square root of a negative number depending on what x is. So we're going to start by making the restriction that x plus 2 must be greater than or equal to 0. Okay, so what we're saying is what's inside of the square root can't be negative. Okay? This then tells us that x is greater than or equal to negative 2. Okay? Now in interval notation, this is negative 2, all of those numbers that are bigger all the way up towards infinity. Okay? So the domain of the function in interval notation is negative 2 to infinity. Okay, the second question asks us what is the range of the function in interval notation. And notice I make a big point of saying to be careful. Okay, so one way we can start to solve for the range of the function is by solving for y. Solving for y in the equation y equals our f of x, which is here negative square root of x plus 2 minus 3. So we're going to solve for x there. So we then get that negative the square root of x plus 2, I'm just switching the sides of the equality, and I'm adding 3 to both sides, is equal to y plus 3. Then I'm going to multiply through by negative 1. So I get the square root of x plus 2 is equal to negative y minus 3. Okay? Now I square both sides. X plus 2 is equal to negative y minus 3 squared. And then I subtract 2. Okay? So this tells us if we listen to what this says that there are no restrictions on y, so our answer would be all real numbers. However, this isn't correct. Okay, so I say be careful over here because notice our function is negative the square root of x plus 2 minus 3. Okay, so we have to ask ourselves, so given our domain, what can come out of this function? So if I put in negative 2 into my function, I get 0 for this negative the square root of x plus 2, I get, and then minus 3. So 0 minus 3, I get negative 3. Okay. Now anytime I put any number bigger than negative 2 into this function, I'm going to get something that's positive here, and then I'm going to take the square root of that. And when I take the square root, I take the positive square root, unless I say otherwise, which I do here. I'm saying we're going to choose the negative square root. So I have negative the square root of some positive number minus 3. So that's going to be some number that's smaller than negative 3, that's more negative. Okay, so actually the biggest number I could get here is negative 3. Oops, that didn't do what I wanted. Sorry guys. There we go. Okay, so the biggest number I could get here is negative 3. And I can achieve negative 3 for when x is equal to negative 2. I can also get all numbers smaller than that. Okay? So here, if we just solve algebraically, we don't actually get the correct answer, right? Whenever we have this square root involved, we need to check our answer. And once you check your answer, sorry, that shouldn't be there, that one. So this, once you check your answer, you get the interval from negative infinity to negative 3 inclusive. Okay, so that's the range. So here's the domain, here's the range. Now it asks me to graph this function on the xy plane. Okay, so let's get a new Okay, so we're graphing the function on the xy plane. So first let's just work kind of excuse me, outwards from x. So the first thing that we do to x is replace x with x plus 2. Oh, and first of all, let's recognize what the underlying shape of our function is going to be. So we've got this square root. So the underlying shape of our function is our square root, which looks like this. Okay, so this isn't the graph of our function, but this is going to be the shape of our function. Okay, so the first thing that we do is we translate x. Okay, so we're shifting in the x direction. We replaced x with x plus 2. So this is the square root of x. So we go to the square root of x plus 2. Okay, so this translates -2 units in the x direction. Replace x with x plus 2. We shift -2 units in the x direction. Okay, then we have this negative on that function. So this goes to negative the square root of x plus 2. Okay. Now when we graph that, that reflects this graph about the x-axis. Okay, so where y values used to be positive, now they're negative. Okay, so that shape looks like that. And then finally, we have a negative vertical translation. So negative square root of x plus 2 minus 3. We have a negative vertical translation, so everything shifts down 3 units. So there's the vertex, and then we have that smooth curve down. Okay, so that's the function on the xy plane. And now I ask you, highlight the 2 points, -2, f of -2, and 2, f of 2 on your graph, and draw the line between them. Okay, so here is -2, f of 2. Let's make that a big circle. Here is 2, f of 2. Okay, so I'm going to draw a line between them. There's the line between them. Okay, and then part D, this is kind of just a hint for part D. Part D asks, what is the average rate of change of this function over the interval -2 to 2? Now the average rate of change of a function over some interval is just the slope of the line between the points, B or A, f of A, and B, f of B. Now here our A is -2 and our B is 2. Okay, so we are looking at the slope of the line. So the slope of the line. The slope of the line is f of 2. So the y values, the difference in the y values over the difference in the x values. Okay. Now f of 2 is negative, let's see, 4. So this is negative the square root of 2 plus 2 minus 3. Okay, that's f of 2 minus f of -2, which is negative the square root of -2 plus 2 minus 3, all over 2 minus -2, which is 2 plus 2. Okay, doing a little bit more simplification, we get negative the square root of 4, which is -2. Negative the square root of 4 is -2, minus 3, which is -5. Now this is negative the square root of 0, which is 0. So we just have -3 here. So minus a -3, we get a plus 3 over 4, which is -2 over 4, or -1/2. So the slope of the line between those 2 points is -1/2. Okay, again, let me get a new page. Okay, part F asks us to find the inverse of this function. The first thing, though, it says, what should you ensure before calculating the inverse function? Well, whenever we want to find an inverse function, the first thing we have to ask ourselves is this function invertible, or is this function one-to-one? So, is this one-to-one? The answer is yes. We can see that graphically, or we can do it algebraically. I didn't ask you to do that though, so we won't go over it. Now let's find the inverse of this function. So I set up y equals f of x. So just like when I'm solving for the range, I set up y equals negative f of x, and then I solve for x to find the inverse function, just like I do with the range. Okay, so just like before, I get negative the square root of x plus 2 is equal to y plus 3. So the square root of x plus 2 is equal to negative y minus 3. Square both sides, negative y minus 3 squared, and then subtract 2. Minus 2. Okay, so f inverse of y is equal to negative y minus 3 squared minus 2. Okay, so that's my inverse function. I'm going to rewrite it as a function of x, just to emphasize that we can always rename variables. It doesn't matter what they're represented by. So here before I had y, now I have x. So everywhere I see y, I'm going to replace with x. Okay, and that's my answer. So it doesn't matter what you name your variable, I'll accept the function defined with any variable. I just chose to replace with x so that I have a function of x instead of y. Okay, now going on. The second problem is one of those setting up equations that define functions problems. So the first thing, a circle is inscribed in a square. So let's draw that picture. Here's a horrible square. And inside I will draw an equally horrible circle. Yep, very horrible. Okay, so a circle is inscribed in a square, meaning the edge of the circle just touches the 4 edges of the square. Okay. Find the area of the circle as a function of the length of the side of the square. Okay, so first step, read the question, draw a picture. We've done that. The second is to assign variables to relevant quantities, or name the relevant quantities. Now the relevant quantities here, we're going to have some area, so maybe I'll call that A. And then we're going to have the length of the side of the square. Okay, so I'm going to call the length of the side of the square S. And since it's a square, all of the sides have length S. The third step with these problems is to make note of the equations that you know. So the first thing that we know is that A equals pi r squared. Okay. Now right now we have A as a function of r, the radius. Eventually we want to have A as a function of the length of the side of the square, or A as a function of S. Okay. Now another thing we know is that here is the diameter, and here is the radius. I know that r equals d over 2. Okay. Now the last thing I know I get from the picture, I notice that d, the diameter, is the same length as the side of the square. Okay, so d equals s. Now eventually I want a to be in terms of s. So I'm just going to start plugging things in and see how I can simplify this. Okay, so a equals pi r squared. Now r is equal to d over 2, so I'm going to make that replacement. Okay, d over 2 squared. And then finally, d is equal to s, so I'm going to make that replacement. Okay, let's just for fun square this out. We get pi times s squared over 4. I like to rewrite with all of my constants out front. So it's pi over 4 times s squared. Now this is a function of s, So the area of the circle as a function of the length of the side of the square of S is pi over 4 S squared. Okay.